Hello, this is Lee Montz with GL2M Engineering. This is a video about a chiller plant for an industrial client here in Texas that we recently completed. It's being built right now. It's an interesting plant that it displays a lot of the current technology in terms of what we use today to design and build state-of-the-art chiller plants. This is what's known as a variable primary system. There are two primary chiller plant designs out there and then lots of hybrids. One is called variable primary and the other one is called primary secondary. In a primary secondary system, there is a decoupled pipe and there are pumps that are usually constant volume feeding water to each chiller. And in a variable primary system, which is considered state-of-the-art by today's standards, all of the chillers are capable of receiving variable flow, either or both the evaporator flow and the condenser flow. And the flow diagram is maybe the best way to demonstrate this concept. In this design, we have 3 pumps feeding 3 chillers. And you'll notice that the pumps are not here where the valves are. This is important because now the pumps aren't tied to the chillers. In an industrial plant, everything is reliability must run, RMR we call it. You have all kinds of redundancies built into the system. In this case, this first pump could fail and chiller number 2 could fail, and we could use these 2 pumps with these 2 chillers or any combination of the above. That's important because things are critical in an industrial facility. It's not the same as in a air conditioning application where people just get hot, although that's bad. In an industrial facility, millions can be lost quickly if critical equipment fails. So everything's built with redundancy and backups. As an example, these variable frequency drives all are specified with a bypass on them. So if the electronics were to fail, you can just run it through the electricity through the bypass, and that causes the pump to spin at 60 hertz instead of a reduced speed. That's not the end of the world. It means you're paying for that added cost of electricity that's not needed, and it means your differential temperature will drop, but the system is running. And that's what you want, the system to keep running. When we spec an variable frequency drive for an industrial facility, we typically spec a top quality drive like the Allen Bradley style industrial drives, and we spec them with a bypass. And there's other things on drives that are important in the spec too that I'm not going to cover in this video. The interesting thing about these chillers, these are water-cooled centrifugals. Centrifugal chillers have some interesting operational things about them. You can spec a 700-ton chiller and get 800 tons out of it. In fact, we spec'd a 750-ton chiller for this same client, and then we tweaked the chiller selection and we were able to get 837 tons out of it. And we didn't have to pay any more for that, except we had to pay for bigger pumps to get rid of the, to flow water through the condenser. We didn't have to pay for a bigger chiller. And pumps are typically inexpensive. It wasn't a super high cost to get an extra 88 tons out of that chiller. And for this particular facility, they'll take all the capacity they can get. This is the chilled water loop, and I'm going to go to the condenser loop now. Again, this is the same thing in pump design where the pumps are separated from the chillers, and we have control valves here where we can open and close these control valves when we're running a pump so that we're not flowing water through a chiller that's turned off. And there's several safeties here that are used to help the maintenance of the plant. An example, differential pressure gauge across the strainer on the inlet to the pump. We've even put differential pressure transducers there that will send an alarm so that they know when that strainer is clogged and they can get out and clean it Again, it's a 24/7 operation, so it's all about reliability. On this facility, they actually have two different types of makeup water for the cooling tower. Back in 2011, we had a drought in Texas, and they had a hard time getting water from the city because the water supplies were at an all-time low. And so they built a redundant backup water supply system that uses the wastewater from their process as makeup water into their cooling towers. It's a smart design. We did a data center for Hospital Corp of America. They didn't have two water supplies, but we put in a tank that was approximately 10,000 gallons that was meant as a backup if the city water supply ever were to go down, which it did at one point. Then they've got enough time to continue operating the plant. They can order water from a water supply company, fill the tank, and run 24/7. The other interesting thing about this design is the facility has a byproduct in their manufacturing process that creates a gas that eats carbon steel. And so this entire plant uses stainless steel pipe. That would be a first for us. Most of the chiller plants that we design would use carbon steel pipe. And also these cooling towers are made by Tower Tech. They're a polyethylene tower. Again, we wanted to not use steel. These towers have multiple small fans on the bottom instead of one or two or three large fans on the top. So if one fan fails, the cooling tower isn't down, and it can be separately maintained. Rather than taking down the whole cooling tower, it actually can continue to run while the fan is replaced. There's more safeties in here, but I don't want to bore you with the details other than to show you that this is a state-of-the-art chiller plant for an industrial facility. This is something else that GL2M does that very few engineering companies do. These are shop drawings. We partner with various contractors to develop chiller plants depending on the application. Some of our work is what they call plan and spec, and some is design build. This is a hybrid. We're working for a developer in this situation, but these shop drawings are for the contractor to build from. We go to the site and we take laser measurements of existing pipe and new pipe from working in 3D. This is all done in Revit, which is a three-dimensional CAD software that's considered state-of-the-art. And we develop assembly drawings of the various components that need to be built for this chiller plant, and the contractor can weld them all up in his shop. And it turns out when you're welding stainless steel, that's more important than when you're welding carbon steel, because if you're welding stainless in outside in a windy environment, it's hard to keep the high purity gases around the weld, and the quality of the weld suffers. And this way, they're going to build these assemblies in their shop, truck them to the site, and then bolt it together on site. It goes together faster. Also, they can build these components while they wait for the chiller to ship. When the chiller ships and they set the chiller, then the time between setting the chiller and installing the pipe goes very quickly. In a facility that's begging for their new chiller plant, this is fast track construction. This is one of GL2M's most recent plants, 3 700-ton centrifugal chillers. It is state of the art. Took it all the way from conception to the shop drawing level, and when the chillers arrive on site, we will work with the chiller manufacturer to commission the plant properly, make sure that all of the controls operate as expected. This is Lee Muntz with GL2M Engineering. We do a lot of chiller plants. We'd like to help you with yours.